Hi students, today we are going to discuss the topic condition for coplanarity of two lines. Condition for coplanarity of two lines. Already you know coplanar. Given the 2 points or 2 lines are in the same plane, given the 2 lines are coplanar. Or 2 lines are parallel, or 2 lines are intersect, given the 2 lines are coplanar. Condition for coplanarity of 2 lines, let R vector equal to A vector plus SB vector be the one of the line, and R vector equal to C vector plus T of D vector is be another line. Let R vector equal to A vector plus S of D is one of the line, and R vector equal to C vector plus T of D vector. 2 lines are coplanar. That is what for condition? Condition for 2 lines are coplanar. The condition for vector form. Condition for first write in vector form. The vector form is C vector minus A vector dot product of B vector cross D vector. C vector minus A vector, that is A and C are given 2 points. B and D are 2 parallels. C minus A dot B vector cross D vector value equal to 0 given 2 lines are coplanar. So that is, this is one of the plane. First line is R vector equal to A vector plus S of B vector, that is the direction is B vector. And this line is R vector equal to C vector plus T of D vector. This line is D vector. 2 lines are parallel. So now find the 2 B vector cross D vector. Now find the B vector cross D vector is B vector cross D vector is a perpendicular. B cross D is a perpendicular vector. B vector cross D vector is a perpendicular vector. Now find C minus A dot B vector cross D vector value equal to 0 given the 2 lines are coplanar. That is for condition for vector form. Condition for vector form is C vector minus A vector dot B vector cross D vector equal to 0 given 2 lines are coplanar. The next one, condition for Cartesian form. Condition for Cartesian form. Cartesian form. 2 lines are already you know condition for 2 lines are intersect. Condition for 2 lines are intersect. Determinant of x minus or x2 minus x1 y2 minus y1 z2 minus z1 L1 m1 n1 L2 m2 n2 equal to 0. Determinant value equal to 0 given the 2 lines are intersect. Intersect mean 2 lines are coplanar. Condition for Cartesian form is given the point. The first point is A is x1 y1 z1. The point C is x2 y2 z2. Now writing a Cartesian form, x2 minus x1 y2 minus y1 z2 minus z1, and the parallel B vector is L1 m1 n1 or b1 b2 b3, you take any one. Now writing L1 m1 n1, and next parallel is D vector. Here D vector is L2 m2 n2 or d1 d2 d3, you take any one. This L2 m2 n2 equal to 0 given 2 lines are intersect. Intersect means 2 lines are coplanar. 2 lines are coplanar, that is the condition for vector form and Cartesian form. Vector form is C minus C vector minus A vector dot B vector cross D vector equal to 0. 2 lines are coplanar. Next one, Cartesian form is determinant of x2 minus x1 y2 minus y1 z2 minus z1, where x1 y1 z1 be the one of the point, x2 y2 z2 be the another one point, L1 m1 n1 be the first parallel, that is the parallel is B vector, that is the direction. L1 m1 n1, L2 m2 n2 means is the second parallel or second direction. Writing a determinant value equal to 0, 2 lines are coplanar. The next one topic, equation of plane containing 2 non-parallel coplanar lines. Equation of plane containing 2 non-parallel coplanar lines. given two non-coplanar lines, let r vector equal to a vector plus s b vector and r vector equal to c vector plus p d vector be two non-parallel coplanar lines. Let r vector equal to a vector plus s of b vector be the one of the line and r vector equal to c vector plus t of d vector be two non-parallel. Non-parallel means b and d are, that is b is not a scalar multiple of d vector. B and d are non-parallel coplanar lines. Now find the equation of the plane. In first one write in a parametric form. It's a parametric form. Given two lines, r vector equal to a vector plus sb vector and r vector equal to c vector plus td vector. Now write in a parametric form of equation of the plane is, first write in r vector equal to, first now taking any one of the points r vector equal to a vector. Here a is the one of the point. Now I am taking a first one of the point a vector, r vector equal to a vector plus and two non-parallels and two, take the two parallels SB and TD, or SB the parameter, B vector and D vector be the two parallels. Now find the parametric form of Cartesian plane is, now write in a vector form, r vector equal to, you take any one of the point, first taking the point a vector plus SB vector plus TD vector be the parametric form of equation of the line. First one. Or taking the another one point C vector, you take any one point A or C. Now taking the point is C. Now write in the parametric form r vector equal to C vector plus SB vector plus TD vector. C vector plus SB plus TD vector is the parametric form of vector equation. R vector equal to A be the taking any one of the point A or C. First now taking the point A vector plus two parallel B and D. Next taking the point C, take any one point A or C. Taking the point C is R vector equal to C vector plus SB vector plus TD vector is the parametric form of vector equation. The next one, non-parametric form. That is a non-parametric form. Non-parametric form of vector equation. R vector, non-parametric, R vector minus A vector. R vector minus A vector dot, R vector minus A vector dot B vector cross D vector. R vector minus A vector dot B vector cross D vector equal to 0 is a non-parametric form. Or first take the point A. Next one, this line is the non-parametric form is R vector minus C vector dot B vector cross D vector equal to 0 is the non-parametric form of vector equation. Next to find Cartesian form. To find Cartesian form of equation of plane. Next one, Cartesian form. First now I am taking a first point. Here the point A is x1, y1, z1. The point C is x2, y2, z2. Now taking the first one of the point is x minus x1, y minus y1, z minus z1. And two parallels. B vector be the one of the parallel and D vector be the another one parallel. Now write in a parallel is L1, M1, N1, L2, M2, N2 equal to 0 is a Cartesian form of equation of the plane. You taking any one of the point x1, y1, z1 be the taking the one of the point. Or now taking the second point, that is the equation of the plane is x minus x2. So taking the second point x minus x2, y minus y2, z minus z2. Already the parallels are L1, M1, N1, L2, M2, N2 equal to 0 is a Cartesian form of equation of the plane. Now discuss exercise 6.8 problems. The first one, show that the straight lines r vector equal to 5i vector plus 7j vector minus 3k vector plus s of 4i vector plus 4j vector minus 5k vector and r vector equal to 8i vector plus 4j vector plus 5k vector plus t of 7i vector plus j vector plus 3k vector are coplanar. Given the two lines are coplanar, find the vector equation of the plane in which they lie. Given two straight lines are coplanar, already you know given two straight lines are coplanar, what is the condition for two lines are coplanar? That is a condition for coplanar, that is a vector form and a Cartesian form. The vector form is c vector minus a vector dot b vector cross d vector equal to 0 given the two straight lines are coplanar. Or Cartesian form is the determinant of x2 minus x1, y2 minus y1, z2 minus z1, L1, M1, N1, L2, M2, N2 equal to 0 given that two straight lines are coplanar. And next find the vector equation of the plane. Find the vector equation. Given two lines, find the vector equation of the plane is parametric form of vector equation of the plane is r vector equal a vector. Take any one of the point. A vector or c vector. R vector equal to a vector plus s b vector plus t d vector is the vector equation of the plane. Or r vector equal to c vector plus, you take any one of the point c vector. This point c vector equal to s b vector plus t d vector, that is a vector equation of the plane. So now first find given the two straight lines are coplanar. So that verify given the two lines are coplanar. Solution. First write in a vector, that is the point is a vector equal to 5i vector plus 7j vector minus 3k vector, that is the point is a, and the second point c or a vector plus sb vector, r vector equal to a vector plus sb vector, that is b vector equal to b vector be the parallel 4i vector plus 4j vector minus 5k vector be the parallel. And the point c vector equal to, c vector is 8i vector plus 4j vector plus 5k vector, that is the point c. And d vector is 7i vector plus j vector plus 3k vector, that is a parallel d vector. Now show that given the two lines are coplanar, for the condition is c minus a dot b vector cross d vector equal to 0. Now first find c vector minus a vector. C vector minus a vector equal to c minus a. 8i minus 5i, 8 minus 5, 3i vector. Next one 4 minus 7, 4 minus 7 minus 3, minus 3j vector. Next one 5 minus 3, already minus or minus plus, 5 plus 3, 8. This 8k vector is c minus a, that is the c minus a. Now check c minus a dot b vector cross d vector. B vector cross d vector equal to 0 given the two lines are coplanar. Already c minus a, find the result 3i minus 3j plus 8k. Next find the result b vector cross d vector. Now find b vector cross d vector. Now find b vector cross d vector equal to vector product of two vectors by using determinant form. Determinant of I vector, j vector, k vector. The component of b vector is 4 minus 5, and the component of d is 7, 1, 3. 7, 1, 3. Now expanding the determinant, I vector into 4 3s are 12, formula minus 1 into minus 5, already minus or minus plus 5, minus j vector into taking a element j, column and row are eliminating the minor matrix. 4 3s are 12. 4 3s are 12. Next one, 7 into minus 5, minus 35. Minus 35, already formula is minus plus 35. Plus 35. Plus, taking the element k vector into 4 1s are 4. 4. Next one, 7 4s are 28, minus 28. Minus 28. This is equal 12 plus 5. 12 plus 5, 17. 17 I vector. Next one, 12 plus 35, 47. Minus 47 j vector. Next one, 4 minus 28. 4 minus 28 is minus 24. Minus 24 k vector is b vector cross d vector. This is b vector cross d vector. B vector cross d vector is 17 I vector minus 47 j vector minus 24 k vector is b vector cross d vector. Now check c vector minus a vector dot b vector cross d vector equal to 0 given that two straight lines are parallel or coplanar. Now check c vector minus a vector dot b vector cross d vector equal. Already find c vector minus a vector is 3i vector minus 3j vector plus 8k vector dot b cross d 17 I vector minus 47 j vector minus 24 k vector. This b vector cross d vector. Now find dot product of two vectors. Dot product of two vectors. Now multiply 17 into 3. 17 into 3, 51. 51 I vector. Next one, minus into minus plus. Minus into minus plus. 47 into 3. 47 into 3, 141. 141. Next one, plus into minus minus. Plus into minus minus. 24 into 8 is 192. 51. 17 into 3, 51. Next one, minus into minus plus. 47 into 3, 141. Plus into minus minus 88 into minus 24 is 192. Now add the value. 51 plus 141, 192. 192 minus 192, the value is 0. So c vector minus a vector dot b vector cross d vector equal to 0. Therefore, given that straight lines are coplanar. Given that straight lines are coplanar. Next, find the vector equation of the plane. Now find the vector equation of the plane is vector equation of the plane, that is here writing a vector form is r vector equal a vector plus sb vector plus td vector. Take any one of the point a vector, or r vector equal to c vector plus sb vector plus td vector. Take any one of the point. Now write in r vector equal to, take the point a vector. Here a vector is 5i vector plus 7j, 5i vector plus 7j vector minus 3k vector plus s of b vector is 4i. S of 4i vector plus 4j vector minus 5k vector plus t of d vector is d vector 7i plus j vector plus 3k vector. That is a vector equation of the plane. You take r vector equal to a vector, take any one other point. R vector equal to a vector 5i plus 7j minus 3k. You take the point c vector. R vector equal to c vector plus sb plus td vector. Here the point c vector is r vector equal to c vector. Here c vector is c vector 8i plus 4j plus 5k. 8i plus 4j plus 5k plus s of 4i plus 4j minus 5k plus t of this one. That is a vector equation of the plane. Next problem, second problem. So that the lines x minus 2 by 1 equal y minus 3 by 1 equal z minus 4 by 3 and x minus 1 by minus 3 equal y minus 4 by 2 equal z minus 5 by 1 are coplanar. Find the plane containing these lines. First, now show that the result given the two lines are coplanar. Given the two lines are coplanar using vector form or Cartesian form. Vector form is c vector minus a vector dot b vector cross d vector equal to 0. Given the two lines are coplanar. Cartesian form x2 minus x1, y2 minus y1, z2 minus z1, L1, M1, N1, L2, M2, N2 equal to 0. Given the two lines are coplanar. So that the result, two lines are coplanar, first one. Next find the equation, the plane containing these lines. Given two lines, find the equation of the plane. Already you know formula, given two lines is, given two lines, find the equation of the plane is, find the equation of the plane, parametric form or non-parametric form or Cartesian equation of the plane, anyone. You take Cartesian form of the equation is, you take any one of the point, x1, y1, z1, you take the any one of the point. Now write the formula, determinant of x minus x1, y minus y1, z minus z1, L1, M1, N1, L2, M2, N2 equal to 0, getting the equation of the plane. You take the another one point, C vector is x2, y2, z2. Write in a formula, x minus x2, y minus y2, z minus z2, L1, M1, N1, L2, M2, N2 equal to 0, you get the Cartesian equation of the plane. So, first, now show that the result given two lines are coplanar. Now, write in here, first one points are, let A vector, that is a Cartesian form, numerator is the points and the denominator is the parallel. Formula is x minus x1, this x minus x1, that is a minus 2, x1 value 2. Y minus y1, here y1 value 3, formula is minus. x1 value 2, y1 value 3 and z1 value is 4. Next write in a b vector is 1, 1, 1, that is a 1 I vector plus j vector plus k, 3k vector, that is a parallel. Same Cartesian form is x minus x1, y minus y1, that is the x2 the point or x minus x2, that is the x2 point 1, y2 4, z2 plus 5 and the parallel minus 3, 2, 1 are parallel. First one write in here, point x1, y1, z1 equal to the point x1, y1, z1 equal to 2, 3, 4. And the second point x2, y2, z2 equal to 1, 4, 5. That is the point is 1, 4, 5 is x2, y2 and z2. And the parallel are taken L1, M1, N1. Is L1, M1, N1 equal to 1, 1, 3. And L2, M2, N2 equal minus 3, 2, 1. Minus 3, 2, 1. That is the second point. Now, so that the result, two lines are coplanar. For condition for two lines are coplanar, condition for two lines are coplanar, or condition for two lines are intersect, it is a determinant of x2 minus x1, y2 minus y1, z2 minus z1, L1, M1, N1, L2, M2, N2 equal to 0. Getting the result equal to 0 given the two straight lines are coplanar. Now check, now substitute the value, that is implies the determinant of x2 minus x1, x2 minus x1, x2 minus x1 is 1 minus 2, 1 minus 2 minus 1, 1 minus 2 minus 1. y2 minus y1, 4 minus 3, 4 minus 3, 1. 5 minus 4, 5 minus 4, 1. 5 minus 4, 1. Next one, L1, M1, 1, 1, 3. 1, 1, 3. Next L2 M2 N2 minus 3 2 1 minus 3 2 1. Now check the result. That is implies minus or equal, that is equal minus, taking the element minus 1 into 1 into 1s are 1 minus 3 2s are 6 minus 6 minus 1 into column and row are eliminated, getting the minor matrix 1 1s are 1 formula minus 3 into 3 minus 9 formula minus 3 3s are 9. Taking the element 1 plus 1 into column and row are eliminated, getting the minor matrix 1 2s are 2 formula minus 3 into 1 minus 3 minus or minus plus 3 equal minus 1 into 1 minus 6 minus 5 minus or minus plus 5. Next one 9 plus 1 10 minus 10. 2 plus 3 5 into 1 is 5. This 5 plus 5 10 10 minus 10 is 0. This is equal to 0. Therefore the given lines are coplanar. The determinant value equal to 0. Therefore the given lines are coplanar. Next find the equation of the plane containing these lines. Find the equation of the equation of the plane containing these two lines. Now taking the any one of the points x1 y1, now taking the x1 y1 z1, and the parallel are L1 M1 N1 and L2 M2 N2 are also the parallel. Now write in a Cartesian form. Cartesian form is determinant of x minus x1, y minus y1, z minus z1, L1 M1 N1, L2 M2 N2 equal to 0 is a Cartesian form of a equation of the plane. Now substituting x minus x1, already point x1 is minus 1 comma 1 comma 1, that is x plus 1, that is the point is minus 2 minus 3 minus 4, x minus 2 y minus 3 z minus 4. The point x1 y1 z1 is 2 3 4, x minus 2 y minus 3 z minus 4 is the, taking the any one other point. You take x2 y2 z2 is formula x minus x2 y minus y2 z minus z2. You take the second point or take the first point. You take any one of the point. Alright, L1 M1 N1 is L1 M1 N1 1 comma 1 comma 3 1 1 3, and L2 M2 N2 is minus 3 2 1 equal to 0. Now expanding the determinant, this implies x minus 2 into 1 1s are 1, 2 3s are 6 minus 6. Next one minus of y minus 3 into getting the minor matrix 1 into 1 1 formula minus 3 into 3 minus 9 minus or minus plus 9. Next one plus z minus 4 into 1 2s are 2 formula minus 3 into 1 minus 3 minus or minus plus 3 equal to 0. That implies x minus 2 into minus 5, 1 minus 6 is minus 5 minus y minus 3 into 9 plus 1 is 10 plus z minus 4 into 2 plus 3 5 equal to 0. Now multiply minus 5 dx minus 5x minus into minus plus 5 2s are 10. Next one minus y into 10 minus 10y. Next minus into minus plus 10 into 3 plus 30. Next one 5 into z is 5z plus 5z minus 5 4s are 20 equal to 0. Minus 5x plus 10 minus 10y plus 30 plus 5z minus 20 equal to 0. Now arrange in x, y, z. Arrange the equation. That is implies minus 5x minus 10y plus 5z and the constant term, the 10 plus 30, 40, 40 minus 20, 40 minus 20 plus 20 plus 20 equal to 0, 20 equal to 0. Minus 5x minus 10y plus 5z plus 20 equal to 0. This equation is divided by minus 5. This equation is divided by minus 5. That is implies minus 5 by minus 5 is x plus x. Next one plus minus minus cancel. 2 5s are 10. 2y. Next one minus z minus 4 5s are 20 equal to 0. That is x plus 2y minus z minus 4 equal to 0 is a Cartesian equation of the plane containing these two lines. That is a Cartesian equation of the plane. Next one, third problem. If the straight lines x minus 1 by 1 equal y minus 2 by 2 equal z minus 3 by m square and x minus 3 by 1 equal y minus 2 by m square equal z minus 1 by 2 are coplanar, find the distinct real values of m. So given two lines already are coplanar. Given the two lines are coplanar, find the distinct real values of m. Already you know, given two lines are coplanar, already you know condition for two lines are coplanar, vector form or Cartesian form. So writing a Cartesian form is x2 minus x1, y2 minus y1, z2 minus z1, L1, M1, N1, L2, M2, N2 equal to 0. That is a given two straight lines are coplanar. Now find the distinct real values of m. Distinct real values of m. It is the real, find the real values of m value. Given two lines are coplanar. Now write in your points x1, y1, z1 equal to, that is the first line is x1, y1, z1. That is the point 1, 2, 3. The point is x1, y1, z1. And x2, y2, z2 equal, the point x2, y2, z2 is 3. X minus x2, 3, 2, 1. Is the point x2, y2, z2. Next one, the parallel L1, M1, N1 equal to 1, 2, m square. And L2, M2, N2 equal to 1, m square and 2. That is L2, M2, N2. Condition for two lines are coplanar. Condition for two lines are coplanar. Two lines are coplanar in Cartesian form. In Cartesian form is determinant of x2 minus x1, y2 minus y1, z2 minus z1, L1, M1, N1, L2, M2, N2 equal to 0, equal to getting the result equal to 0, given the two straight lines are coplanar. Already given the two lines are coplanar, that is equal to 0. Now substitute the value x2 minus x1. That is the point is x2 minus x1, 3 minus 1. Write in determinant of, that is implies x2 minus x1, 3 minus 1, 2. 3 minus 1, 2. x1, 2, y2 minus y1, 2 minus 2, 2 minus 2 is 0. 2 minus 2, 0. x1 is z2 minus z1, 1 minus 3 minus 2. Next one, L1, M1, N1. L1, M1, N1 is 1, 2 m square. 1, 2 m square. And L2, M2, N2 is 1 m square to 1 m square 2 equal to 0. Equal to 0 means given that two straight lines are coplanar. Now expanding the determinant 2 into 2 2s are 4. Formula minus m square into m square is m power 4. Next one, taking the element 0. 0 into anything value is 0. Next one, taking the element is 2 minus 2 into 1 into m square is m square minus 1 2s are 2 equal to 0. That is implies multiply by 2, 2 4s are 8, 2 4s are 8 minus 2 times of m power 4, 2 times of m power 4 minus multiply by 2 m square, 2 m square. Next one minus and minus plus, 2 2s are 4 equal to 0. 4 equal to 0. That is implies minus 2 m power minus 2 m power 4 minus 2 m power 4. Next one minus 2 m square. 8 plus 4. 8 plus 4 is 12 plus 12 plus 12 equal to 0. Plus 12 equal to 0. Minus 2 m power 4 minus 2 m square plus 12. That is the equation is divide by minus 2. That's the equation is divide by minus 2. That is implies m power 4 plus m square, m power 4 plus m square minus 6 equal to 0. Minus 6 equal to 0. M power 4 plus m square minus 6 equal to 0 is, this is a quadratic equation. This 1 into minus 6 minus 6 multiply by 2 values, 2 3s are 6, 2 into 3s are 6, getting the positive center values is positive, center values is positive, smallest values is negative. M 3 into minus 2 minus 6, add the two values, 3 minus 2 is 1. Now get the result. That is implies m square minus 2, one of the factor, and next one factor is m square plus 3 equal to 0. M square minus 2 into m square plus 3 equal to 0, getting the two result. That is implies m square minus 2 equal to 0, another result, and another one result m square equal to or m square plus 3 equal to 0, getting the two factors. First one m square minus 2 equal to 0, m square minus 2 equal to 0, m square equal to plus 2, m square minus 2 equal to 0, m square equal to 2, that is m equal to plus or minus root 2, m equal to plus or minus root 2. Next one m square plus 3 equal to 0, m square equal to minus 3, m square equal to minus 3. This m equal to plus or minus I root 3, m equal to plus or minus I root 3, that is a complex number, m equal to plus or minus I root 3. Now find the result is distinct real values of m, real values, therefore the m value is plus or minus root 2, therefore the value of m equal to plus or minus root 2. A distinct real value, therefore the value m equal to plus or minus root 2. Next problem, fourth one. If the straight lines x minus 1 by 2 equal y plus 1 by lambda equal z plus 2 and x plus 1 by 5 equal y plus 1 by 2 equal z by lambda are coplanar. Find lambda and the equation of the plane containing these two lines. Given two lines are coplanar, find the value of lambda and the equation of the plane containing these two lines. First, find the value of lambda. Already two lines are coplanar, then find the value of lambda. And next find equation of the plane containing these two lines. Equation of the plane containing these two lines. Already given two lines are coplanar. By using Cartesian form, now writing a first point is x1, y1, z1 equal to 1 minus 1, that is y minus y1 is minus or minus plus. 1 minus 1, 0. Z minus z1, z1 value is 0. Next one, x2, y2, z2 equal to x2, y2, z2 equal 1, minus 1, comma 0. Next one, L1, M1, N1 equal to 2 lambda 2, and L2, M2, N2 equal 5, 2, lambda. That is a given data. The point x1, y1 is z1, x2, y2 is z2, L1, M1, N1 and L2, M2, N2. Condition for two lines are intersects. Condition are coplanar. Given the two lines are coplanar. Given the two lines are coplanar, that is a condition of determinant of condition x2 minus x1, y2 minus y1, z2 minus z1, L1, M1, N1, L2, M2, N2 equal to 0. Equal to 0. Now substitute determinant of x2 minus x1. x2 minus x1 is x2 minus x1. Minus 1 is minus 2. Minus 2. Next one, y2 minus y1. Minus 1 minus half minus plus. Minus 1 plus 1. Minus 1 plus 1 value is 0. x1 0 minus 0 is 0. This is a determinant of. Okay, determinant of. Next one, L1, M1, N1 is 2 lambda 2. Next one, L2, M2, N2 is 5 2 lambda. 5 2 lambda equal to 0. Equal to 0. Now expanding the determinant. You taking the element minus 2. Taking the element minus 2. Getting the minor matrix, this one. Lambda into lambda, lambda square minus 4 equal to 0. Next one, taking the element 0. 0 into anything value is 0. Next taking the element 0, otherwise 0. Now taking the element 2, that is implies minus 2 into, taking the element minus 2 into getting the minor matrix lambda into lambda, lambda square. Lambda square minus 4. Minus 4 equal to 0. Other one 0. 0 into anything value is 0. Next one 0. 0 into anything value is 0. That is 0. That is implies minus 2 into lambda square minus 4 equal to 0. Minus 2 that side value is 0. Lambda square minus 4 equal to 0. That is lambda square equal to 4. That is implies lambda equal to plus or minus 2. That is lambda square root on both sides. Lambda square root cancel, root 4. Root 4 is 2. That is a plus or minus 2. Here lambda value is, therefore the value of lambda equal to minus 2 comma plus 2. Plus or minus 2 is minus 2 comma plus 2. Now find the equation of the plane containing these two lines. Here the lambda value minus 2 or plus 2. Now substitute the value here, lambda value 2. Here lambda value 2. Next one, here lambda value is minus 2. Lambda value minus 2. Now find the equation of the plane. Therefore the equation of the plane is, equation of the plane in Cartesian form is written x minus x1, y minus y1, z minus z1, L1, M1, N1, L2, M2, N2 equal to 0. Equation plane in Cartesian form is you take any one of the point x1, y1 is z1 or x2, y2 is z2. Take any one of the point. Taking the point is x1, y1 is z1. Now substituting x1, y1 is z1 value, x1, y1 is z1 is a point x minus x1 point minus 1, x minus 1 and y plus 1 z minus 0. Z minus 0. This is a z value, z minus 0. Next one, L1, M1, N1. L1, M1, N1 is 2 lambda 2. 2 lambda 2. And L2, M2, N2. N2, M2, N2 value 5 2 lambda. 5 2 lambda equal to 0. Equal to 0. That is the equation of the plane. Then now write in a Cartesian form. Taking the first point x1, y1, z1 is x minus 1, 1 comma minus 1 comma 0, 1, 1, 0 and L1, M1, N1 is 2 lambda 2 and L2, M2, N2 is 5 2 lambda equal to 0. Getting the result already, find out the lambda value is lambda equal to plus or minus 2. Plus or minus 2. Now taking the first value is lambda. Case 1. First case, lambda value, put the value lambda equal to 2, getting the equation of the plane. Put the value lambda equal to 2, substituting the determinant, is a determinant of x minus 1, y plus 1, z minus 0, 2, 2, 2, put the value 2. And the 5, 2, 2 equal to 0. Now expanding the determinant. That is implies first one x minus 1 into 2 to are 4 and x1 minus 4 plus y plus 1 into y plus 1 into this one 2 to are 4 minus 10. Next one plus z into 2 to are 4, 5 to are 10, minus 10 equal to 0. Implies 4 minus 4 is 0. 0 and anything values is 0. Total values is 0. Next one 4 minus 10. 4 minus 10 is minus 6. Multiply by minus 6, minus 6y, minus 6y. Next one minus 1 into 6 are 6. Next one 4 minus 10. 4 minus 10 is minus 6. Multiply by minus 6. Minus 6 is equal to 0. This equation is divide by minus 6. Divide by minus 6, that is implies y plus z plus 1 equal to 0. 0 is one of the Cartesian equation of plane. And case 2, put the value lambda equal to minus 2. Put the value lambda equal to minus 2, substitute in the determinant. Determinant of x minus 1, y plus 1, z minus 0 is z. 2 minus 2, lambda value minus 2, 2. Next one 5, 2, here lambda value minus 2 equal to 0. Now expanding the determinant, that is implies x minus 1 into minus plus 2 to are 4. 2 to are 4. Formula is minus 2 to are 4. 2 to are 4. Next one plus taking the element minus of y plus 1 into 2 into minus 2 minus 4. 2 into minus 2 minus 4. 5 to are minus 10. Taking the element z plus z into 2 to are 4. Next one 5 to are 10 plus 10 equal to 0. This implies 4 minus 4 is 0. 0 and anything value is 0. Next one minus 4 minus 10 minus 14. Minus 14 multiply minus into minus plus 14y. Minus into plus is minus. Plus minus into plus is minus 1. Minus 14 is plus 14. Next one for 10 plus 4 is 14 plus 14 is that equal to 0. That is implies 14y plus 14 z plus 14 equal to 0. This equation is divided by 14. This equation is divided by 14. That is implies y plus z plus 1 equal to 0 is the equation of a plane. Already first equation is y plus z plus 1 equal to 0 is one of the equation, and the second equation is also y plus z plus 1 equal to 0 is the equation of a plane. Therefore y plus z plus 1 equal to 0 is a Cartesian equation, the plane containing these two lines.